Hi everybody, Luke Gallant here from the YT624EJ maintenance channel. It's been a winter with not too much snow here where I live, so the snowblower hasn't gotten much use. In any case, I got a couple subjects here for videos that I'd like to get filmed and get published online for you guys. One of the things that hit me recently is this chute, and I'd like to spend a little bit of time working on it and documenting it for everybody. So I'm not going to show it now, but this chute, it goes up fully. But when I pull the lever in, it doesn't go down to the angle I would like. So it maybe only goes down to this angle, but I'd like for it to be able to point right down. So I'm gonna play with the adjustment, recording each position, and I'd like to get the chute to be able to point more down than it does. So I'm gonna show the extremes of that after. The other thing I wanna do with the chute, I get quite a few inquiries about the chute not turning as it should, and people wondering if it's the switch or if it's the motor, that kind of thing. So I'm gonna take a few readings on my unit, which does work, and and by documenting that, it'll allow you guys to maybe check yours if it's not working, so that you don't buy a switch or a motor unnecessarily. You only troubleshoot and fix what's broken. So we'll start off with those two things, and yeah, thanks for watching. So we're gonna start things off with the excessive service manual referencing. The first bit here is about checking the chute deflector control lever and chute direction control lever. So I'll let you guys pause that and read that on your own. So here we've got a section on the chute control and lighting systems. So if the chute fails to rotate, this is what you would need to do. And then it continues on. And the part I want to focus on is this connector. So forging on with the excesses, I've installed this tilt box angle gauge on our chute. I've got the snowblower level on the ground, fully up. I'm going to measure the angle of the chute. At this extreme upper angle, I've got about 62.1 degrees. And if I push the chute all the way down to kind of its extreme, which is a little bit crazy, we've got about 70 degrees there. So we have about 130 degree angle on the chute there. And now I'm going to actuate my chute here and see what angles we get out of it. So with the lever at the back position, we've got the chute there all the way at the top. And if I move the lever forward, I see that I don't get much action until about here. Now here I've got the lever shaft in line with kind of the middle of the yellow on the center symbol here. Now if I push the lever all the way to the front, I get that kind of action. And the most I can get is 2 degrees. So the chute is almost horizontal. And for me, if I recall with this snowblower, the chute would go down, I would say, probably to more like this, 24 degrees, because then you can shoot the snow into the ground. So again, here I'm about level at 3 degrees, and then I go up. I'm about 3 degrees low, then I go to 0, and then I go up again, and up is like 50 to 60 degrees. So I'm gonna take a crack at an adjustment here, and we'll see where we get. So here we have the adjustment location for the chute height pointing. When I take a measurement here, I see we've got about 12 millimeters of thread exposed. What I need to do to get more action out of this is tighten up the cable a little bit. I would need to take this adjustment and I think bring it down to tighten up the cable a little bit. So here we go. We're going to loosen that nut, and then we're going to back this nut off so that we can kind of, let's say we just kind of go like this and then try this. Let's say we go a little bit more. All right, so we've made the adjustment. We've taken the slack out of the cable, which it seemed like a lot of slack to take out, but anyway, now we've got the chute starting to act maybe, I'd say a good inch, a solid inch before. And now we see that the ultimate angle is definitely more, it's better. So we've got about 14 degrees now. So we've got about 10 degrees in addition. It's not really as much as I'd like, but I don't see what else has changed here. I can actually try and adjust this one a tiny bit just to get what it does, but there's not much thread here. It's not really adjustable, actually. We could probably get like 1 or 2 turns out of it in threads, but there's not really much there. So I think we're kind of stuck with that for the moment. None of these ends are adjustable either. It'd have to be re-crimped. I'm not doing that. So we all love our blue machines here. Try a bit of a hack here. I don't like that we're losing all our blue paint here. So I'm gonna clean this area up with alcohol and take some steps in order to put a stop on our paint loss here. So we're gonna use some genuine Canada Post tape here. All right, so that'll protect the paint for a bit. So we're gonna have a look at the workings of this switch, and to do that, we'll take this cover off. So here we've got the cover off, and we've got the control lever, small linkage, then we've got the switch itself. So control lever to the left, switch goes to the left, control lever to the right, the switch goes to the right. Now the first observation I see here is that from the center position to the right, there's a lot of slop in there. And the switch would only engage when we hear that clicking motion. Listen. On the left, it's very good and strong. But on the right, there's all that slop and we're catching just the end of it. So I don't know if that's a new thing. I don't write everything down actually. But I think what we can do in the meantime, considering we do hear the click, the switch will make. I'm going to pull the connector out from underneath and we're going to have a look at the wiring and how to meter it out per the diagram. All right guys, so I've unplugged the connector. This is the piece that goes down to the motor and down to the battery side of things. Whereas the other end from underneath, which I'll show, is the part that, you know, comes from the switch itself. So let's take some readings. If I had $1 for every time I had to refilm a clip because of a camera issue. So what we're gonna do is take a look at the connector using the service manual. This is the view of the connector when you're looking into the connector. This is the tab here on this triangle. And so when we look into the connector, we have the IRG terminal on the top left, the W in the top middle, the ARW in the top right, and then here these three on the bottom. Notice that there's terminals that have the same name, and that's because on the machine side they are jumpered together. ARW is jumper to ARW, IRG jumper to IRG. So we're going to test 4 positions of continuity, these 4 here. This center is when the lever is in the center position, so there's no continuity. When the lever is in the left position, so they drew this backwards, but anyway, when it's in the left position, we should have continuity on the ARW of the W, here on the IRG, the ARN. On the right, we should have continuity on W and IRG, and then we should also have continuity on the ARN, ARW. I've checked this out already. The bottom 3 that are noted here, that's on the top of the connector. So this IRG, W, ARW lines up to this, and on the bottom, ARW, ARN, IRG lines up to this. I'm not going to install these jumpers to do this testing, so I can make sure that I test the contacts one at a time. So I'm going to position the camera from underneath, and I'm going to show how to test these and what you should expect to see. So a question some of you are asking, I'm sure, is it's all good, but I don't even know how to use my multimeter. So take your multimeter, whatever model it is, you want to find the ohm symbol, or you can find this kind of sound wave type symbol. And you switch to that mode. I won't use the ohm symbol in this case. I'm going to use the sound symbol. So that sound symbol means it's going to make a sound when you have continuity. So here I've got the probes in the ohm symbol. So the ohm and the sound, the probe goes here onto the common. Do not put it into the current symbol. So you'll see here when I touch the 2 wires together, I get continuity and the resistance is shown there. So if I do a decent connection, I'll show that I have 1 ohm, or it could be less, but anyway. And we're going to hear that sound. Here we've got our connector in view. I've managed to put the diagram in as an overlay here. And we've got the meter in the background. So let me put the light on the meter maybe. There we go. So we're going to start here with the W and the IRG on the top. There we go. We're in the top left and the top middle position. The book tells us, after doing some reverse engineering, that if we push the switch to the right, we should hear a beep. There we go. So we hear a beep and we see the meter's got 1 ohm. If we go to the left, we have absolutely nothing. So that's good. Now we're going to move to the W and the ARW. Now when we go left, we get continuity. And when we go right, we get nothing. Okay? Now we're going to try the other position, which is on the bottom, ARN, ARW. When we go to the right, we should get continuity, which we do. When we go to the left, we get nothing. And in the center position, we get nothing. And now we're going to move from the ARN we're gonna move ARN to IRG. Now when we go to the left, we get continuity, and when we go to the right, we get absolutely nothing. And if we go between any of these other terminals, aside from the combinations I just listed, there should be no continuity at all. So I can try one just to say we did, but if I try anything on the top to anything on the bottom, you will not have continuity because they're separate circuits, okay? According to this diagram. So, I mean, that's how you test this switch. So let's do the other side now. All right, guys, here we are with the plug, and I've got the top of the plug is here. So the little clip is here. So I call this the top of the plug. So I've played with it a bit, looking at the drawing, and I don't want to bore anybody with the drawing, so I'm just going to show you guys the facts. The power comes in to the center pins, positive and negative, or I don't remember the order, I'll measure it here. And then it is swapped positive and negative on the exterior pins. So if I turn the key on, I measure for voltage here and here, I've got negatives. So let me flip that polarity for you guys. So on the connector, on the bottom to the top, we've got 12 volts. So 12.07, there were 12.06 volts is my battery voltage, and this should be the polarity. If you measure voltage anywhere else, you won't get anything. And if you turn the key off and you measure for voltage again, you're also not gonna get anything. So this is here, the decay on the starter circuit. You can see it's decaying there. So that's step one. Step two, and by the way, your meter was in DC voltage mode here, okay? If you put your meter in ohms, we'll now measure the resistance of the motor at the other end. So there's the motor turning the chute. We can put our probes in these two locations and we get 1.0 ohms. So that's the resistance of the motor. So if you measure these points, now remember the clip thing is here. So this is the bottom of your plug. If you measure here and you have open, if it says OL or it says open or it says something like 10 kilo ohms or 10 mega ohms, when you measure this, something's wrong between this point and your motor. Your motor could be fried, the breaker in the motor could be open, something's wrong. So you should measure, or at least my machine, I'm not sure, I'm not saying my machine's the baseline for everything here, but I get 1 ohm. If you measure resistance between anywhere else, you're not gonna get anything because only this is connected to the motor. So against my better judgment, I've gone and disassembled the chute rotating switch. It took me quite a while to disassemble it because of the way it's built. I don't feel like doing it again, so I'm gonna show how it's reassembled and show what it looks like inside. In case you guys have issues, you can refer to it. I'm gonna also show what I had to do to get this switch out, and then you can at least know. So I found that really the main way to get the switch out was to get this arm out and then unscrew this little threaded adapter here, and then the switch came out fairly easily. So I love nothing more than to give an explanation when the camera's on pause. Basically here we've got the switch disassembled. If I take the switch out for a minute, we've got the arm on the underside. So that arm, that's the right and the left, and it sits in the center position. So it's upside down now. So if I put this in there, the arm is secured in there with a pin, and then when you tilt the arm to the right or the left, this is what it's doing inside. Now inside here, there's like a little plastic plug with a spring inside. So that spring pushes in when the whole thing is assembled. So there's 2 plugs that sit here with 2 contacts that sit over top. And then these contacts are on the underside and they make with either side here. So you have your positive and your negative coming in, and then you can, you know, when you go left to right, you actuate it like this. So what I was thinking is that maybe the plastic pin that's there was worn, causing this not to work just as well, but I don't think that's the case. I took some photos with my microscope camera. So I'm gonna clean all this, then I'm gonna apply some dielectric grease and reassemble it. You see here, there's 4 holes on the housing, which correspond to these 4, you know, annoying tab style things. So once you press this in, it'll go click all around, and you really have to carefully pry apart this housing without breaking it. So what I actually did, I'm not gonna show it because it was too much of a pain. I would pry apart the housing and then stick a small tie wrap to keep the tab pushed apart. So you do that 4 times, and you got tie wraps flying everywhere. You do it 4 times for every single tab, then it'll allow you to pull the inside of the switch out to have a look if it's broken. So let's go ahead and clean this with alcohol. So we've got a little bit of wear here, but this wear is really not, you can't really even feel it. So it's what I'd say very minor, but you can see the wear obviously. And then on these plugs, which would be very easy to lose, there is actually a decent amount of wear there. So I think that'll contribute to a fair bit of slop as well. So what I think I'm going to do is reassemble this so that these wear patterns are now rotated to get the switch to maybe behave a little bit better. And I think what I'll do is I'm also going to take some measurements so I can 3D print this part and actually have a friend 3D print it. So here we are showing one possible design of a 3D printed plug. Here's another with a slightly different round. So I might give these a try later depending on my experience with the switch. What we can do now is lay down some 600 grit and try to get these small arcing points off the contact. You see that little dot is an arcing point. All right, we're going to go ahead and reassemble. I'm going to attempt to do this with the existing parts, and I've designed new ones to get 3D printed or machined. I'm going to take this dielectric grease. I'm going to put a little bit on the spring. Need 3 hands here really. Put a little bit on the spring. I'm going to take that spring and stick it into the plug. So that's kind of captured in there. And then we'll put some on the bottom of the spring, tiny little bit, and we'll stick that in there. So on my contacts here, I'm going to take the contact that had the most damage and put it against the one that didn't so that it wears the other one. I'm going to load the center portion up with grease and stick it in there so we get it to stick inside, which looks good there. Okay, so now what we're going to do is we're going to take this. On the one side it's got a slot, a groove here, and that slot goes here. So you'll see that slot. We're going to make sure that we're pretty straight here. I'm going to flip it around, make sure nothing drops. We're centered in there. We're going to hold the shaft on the inner side there. I'm going to push that down. And we need to secure that in the vise a little bit more. I'm going to push. Oh, there we go. There we go. There we go. Now we can flip this over. One thing I forgot to say, there's a pin that goes inside here. So here's that pin, guys. I'm going to take that pin, make sure it's aligned. You have to push it in a little bit and then stick the pin through. So from the other side, I'm going to make sure it's aligned and push that pin in. There shouldn't be any forcing going on here. Stick that pin through, and then we're going to use kind of a little pick like this to push that pin through right to the proper point there. We're going to do that, and now we're good. We're nice and centered in there. Okay, so let's try this out. Does it seem to work? Oh, oh yeah. So we're gonna get the grease moving in there. I think that's pretty good. Yeah, I'm okay with this. However, what we want to do before we get this back in the machine is check our resistances again. So here we are. We're gonna start on the center tab up top and go to this side here. Actuate the arm. So the other way. We got 0.6 ohms. I'm gonna go this way. We got 0.6 ohms. So that's it. This switch is good for reinstallation. So I'm gonna go for a major poor man's upgrade on this. I don't like the slop at the end of this arm. I'm gonna put this piece of heat shrink on there and let's see what kind of results we get with it. I went with Yamaha Blue, obviously. All right, here we go with the switch installation. So the switch is keyed, or whatever you want to call it. We're gonna put that up. We're going to take this little thing off, stick that up through there, get the switch to sit in the housing there, and then we can raise this, put this down, screw this down as well. Oh, make sure we don't cross thread it. I'd hate for that to be the culmination of this task. We don't want to over tighten it. Now I had a mark here to where it was, oh no, I've got a washer here. All right, we're going to continue on putting the arm in. I've put Loctite on these 2 bolts, so we'll put those aside. We have to first get the linkage onto this arm, which is a lot more awkward than you'd think, but anyway, no big deal. Okay, we put that in. So guys, it's a crime, but I couldn't find a torque spec on this. So I'll have to go by feel of hand, which I've got a very untrained hand, so what a risk this is. Okay, it seems nice and tight. God forbid we would lose control of our chute during operation. So I got my piece of heat shrink in there, which is going to tighten up that clearance. Let me test this out. It feels good there. Yeah, I like that. It took out that slop that just didn't seem appropriate. It seems that this thing goes further left than it does right. Maybe just the nature of the beast. People like asking about dielectric greasing connectors. This connector has no corrosion, no dirt, no nothing. I don't put grease on them. Plug that in. There we go. So there's this little boot, guys, that you don't want to forget when you put back on. You have to get it down this way and then stretch it over without doing any damage. I'm going to be honest, this is one of the most flexible pieces of rubber that I've ever encountered in my life. So once you get this boot over top, it'll be protected against the elements. I think, what the? Alright guys, one of the tweaks I just did here is I centered this pin. So I punched this pin out a tiny little bit so that it was more centered. I'm going to put a little grease here too, because why not? This pin actually allows the lever to move smoothly. Alright, so I've got really good left to right movement, totally uninhibited. So I'm going to try this again. Alright, let's try this again. We go left. Go right. So yeah, it is going. Believe it or not, guys, I think you got to be really careful for this rubber boot, because if this rubber boot is pushed down, it may actually inhibit the travel. So let's try this again. So we've got our chute moving. Yeah, I think if you guys have some of these failing switches, watch that there's no watch that the slop in here is not too much, because I think that's part of our issue here. I'd like to come up with a way to fix that. All right, guys, so I don't like doing this, but I'm gonna do it. I'm gonna try the real poor man's solution here. So I'm gonna take a piece of wire, of galvanized wire, and I'm going to put a wrap in here so that we kind of hold the way that we hold it. And it's not really the kind of fix I like doing, but I'm gonna try it because it actually costs nothing. So we can go and do that, loop down through here. So we're kind of going to build a knot in there so that we take up that slot, because based on what I can see, that's what's causing our issue here. So I'm going to twist that up. So this is galvanized wire, or maybe stainless actually. I'll show you guys later. So what we're going to do now is install a little bit more in there to take up the rest of the slack. So that seems like it may be sufficient. We're going to wrap it around there. And there's no set order to how you do this. I would you get this rod tied in to as tight as you can to this to take up that slack. So here I've got Home Depot 24 gauge galvanized steel wire. So let's try this again. Oh, that's better. I got that much more positive action with no slop. I can live with that. I'm not sure if you guys can, but I know I can. All right, guys, I want to thank you guys for watching. I hope that I was able to edit this video in a way that doesn't make the whole thing feel as hodgepodge as it did when I was in here working on it. So again, it'll provided you some detail on how to disassemble this whole thing, check out the switch, measure it, troubleshoot it, and to find out what's wrong with yours if it's not working correctly. I think that we've managed to get it working, nice. And we'll see how well it works into the future. But yeah, if you have any questions, let me know. Please like and subscribe, and thanks again for watching.